Within your fingertips are many sensors, feeding you information on the tactile world. Grip, friction, pressure, all these things you need to pick up a pen or feel bumps on a piece of paper. Now researchers have created a synthetic system that captures many aspects of this biological feat. This neuromorphic system uses flexible electronics to sense and report on tactile information. Classical computers get along by crunching large amounts of ones and zeros, which can add up to a lot of energy consumption. We can't have our brains getting hot like an overworked laptop, so our bodies have a super efficient way of dealing with a barrage of input. For example, when there is pressure on many sensors on the skin, those signals are funneled to a single neuron, and if it reaches a certain threshold, that triggers a response that passes the message on. Signals from these neurons converge on the next layer up, which integrates the information further with other sources. Here's how the artificial neuron replicates biology. Touching the pressure sensor increases the electrical voltage between a pair of electrodes in the sensor. That extra voltage is used by a neighboring device called a ring oscillator to create a string of electrical pulses. Those pulses and ones from neighboring ring oscillators are then sent to a third device called a synaptic transistor, which integrates the incoming signals and generates its own series of pulses depending on the pattern it receives. For example, applying steady, soft pressure produces a series of pulses at a different rate than applying more forceful pressure. Researchers showed that they could use their neuromorphic sensors to detect the placement and motion of a small rod across the surface and detect a Braille pattern. They even sent the output electrical impulses to an electrode inserted in the detached leg of a cockroach and showed that the insect's nervous system could receive the pulses and move the leg in response. None of these parts are particularly new, but using them to generate responses to tactile information is. In the future, cheap and efficient systems like these could create large arrays of sensors for prosthetics. And these types of circuits can aid in building robots that can sense and respond to the environment. It's fine to have a pre-programmed bot build a car, but when it needs to respond to changes in the world around it, including moving people, the more senses, the better.